Hello class, welcome to Thal Tutorials. Today we will be discussing the first chapter of physics known as force. Before going deep into this topic, I wanted to define the force as we have done in class 9. It was force is any external cause which changes the shape, motion, size of the body. So what are the things we will be doing in this PPT? After going through this PPT, we'll be able to differentiate between translational and rotational motion. We will be able to define moment of force and torque. We'll also be able to explain what is the clockwise moment and what is an anti-clockwise moment. We'll also be sharing some common examples of moments of force. How would you define couple? And last thing we will be doing in this topic is derivation of moment of couple, that is force into couple arm. So let us go into the topic. So what is translational motion? Translational motion is the motion by which a body shifts from one point in space to another. Or we can also say when a force acts on a stationary rigid body which is free to move, the body moves in a straight path in the direction of the force, that is linear or translational motion. The best example given here is the motion of the bullet fired from a gun. An object has a rectilinear motion. These are the examples for translational motion. So what is then rotational motion? It is a motion which follows a curved path. Example, if a rigid body is moved in such a way that all the particular constitute goes circular motion, that is it moving round and round in the common axis, then that type of motion is known as rotational motion. We can also give an example of a wheel here. What is moment of force? The moment of force is equal to the product of the magnitude of the force and the perpendicular distance of the line of action of force from the axis of rotation. Or we can say, I'll give you an example. We consider a body which is pivoted at any point. If a force is applied horizontally on the body, the force is not able to produce any linear motion, but it is rotating at the same position, that is known as moment of force. The SI unit of moment of force is Newton meter and it is a vector quantity. So moment of force about a point depends on the following two factors. First, the magnitude of the force which is applied there, and what are the horizontal distance or the perpendicular distance of the line of action from the axis of rotation. See, what is clockwise and anti-clockwise moment? If the turning effect on the body is anti-clockwise, the moment of force will also show an anti-clockwise moment, and that will always be taken as positive. While if the turning effect on the body is clockwise, moment of force will be a clockwise moment and it will be a negative moment. See how to decrease the moment of force. See, if we decrease the perpendicular distance from the axis, it also reduces or decreases the moment of that given force. And how to increase the moment? To increase the moment, we'll always have to increase the distance from the axis of rotation where the force would act. This will increase the moment. Here we will be discussing some common examples of moment of force. See, it is very easy to open a door by applying the force at the free end of it because the perpendicular distance is great. So we are requiring a less force to turn the body. Or second example, The stone of hand flour grinder is provided with a handle near its rim. We have never noticed this, but please, why it is there? So it can be rotated easily about the iron pivot at its center by a very small force. See here, this is very important. A small force applied at the handle and we can do such a big work. Another example. We'll always see the bigger thing like truck and bus will have a large diameter in the steering wheel. Why? Because this less force is applied on the steering of large diameter because it is at the large distance from the center of the rim. Now, we have seen wrench, huh? A spanner or wrench has a long handle. Why? To produce larger turning moment. Why? If we get larger turn moment, we will be requiring less force because we will have a greater grip and the perpendicular distance will be at a good place. Last example which we are discussing here, a jack screw has a long arm. Why? So less effort is required to rotate or to lower the jack, which is used to lift a heavy load like a vehicle. What is couple? Two equal and opposite parallel forces not acting along the same line form a couple. A couple is always needed to produce the rotation. A single force applied on a pivoted body does not cause the rotation of the body. Rotation is always produced by a pair of forces. A couple is always needed to produce the rotation. For example, turning a key in a lock or turning a steering wheel is the best example of couple. What is moment of couple? See, the moment of couple is equal to the product of either force and the perpendicular distance between the line of action of both the forces. SI unit of moment of couple is Newton into meter. Now, what are the last thing we will be discussing is the derivation of moment of couple, that is equal to force into couple arm. Class, beware of this. This is very important and it will be coming in your example. Before going into the derivation, I want you to see this diagram very carefully. See, at A and at B, two equal and opposite forces, each of magnitude F, are applied. The two forces rotate the bar in anti-clockwise movement as it has been shown with this and this arrow mark. The perpendicular distance between two forces is AB, which is known as a distance arm as I have shown here. So, moment of force at this point A will be F into OA. F into OA. Okay? And moment of force at B will be F into OB, the distances. So, total moment will be F into OA plus F into OB as I have shown here. If I take F as a common, so F will become here and OA plus OB, where OA plus OB is AB, that is D. So OA plus OB, that is AB, F into AB, or we can write F into distance, which proves either moment of couple is equal to either force into perpendicular distance between the two forces or couple arm. Thus, moment of couple is equal to force into couple arm. This is the last thing we are learning in this PPT. Class, next PPT we will be discussing about equilibrium. Till then, goodbye, take care.